Hey guys, welcome back. So we're going to continue now and implement the velocity check, and I want to explain it quickly using a small example. I'm going to create a wrangle node and say we have a current velocity, which is, I'm going to call it cval, and it's equal to 0, 1, 0. So it's pointing in the up direction, and then I'm going to create an up vector. So it's equal, I'm going to call it up, and it's equal 0, 1, and 0 as well. Okay, and let's do, I'm going to compute the dot product of these two. So v at cd, I'm going to plug this into color, and it's going to be cval, and the dot product between cval and the up vector. And both of them are pointing at the same direction at the same time, right now, sorry. And so the result is 1 because they are both aligned in the same direction. So what we can do is we can start changing the up vector or the velocity. Let's try the velocity. So if it's 0.5, the color is going to change. If it's -1, then it's going to be black. So let's keep this always on top. You can see the color here, and it's actually a float. So let's call this float dot product, and that's the result. So -1 if they're not facing in the same direction, okay, and 1 if they are facing in the same direction. So anything higher than 1 means they're facing higher than 0 means they're getting close to meaning getting close to being aligned and moving in the same direction. So a value of 0.6, if the dot product is higher than 0.5 or 0.6, it means that these two vectors have a higher chance of intersecting with each other. And that's pretty much it, what we're going to implement. So let's do something here, and I'm gonna create a cval. I'm going to call this cval for current velocity, or let's call it v, and it's equal to 1, 0, and 0, for example. And then I'm going to copy the same thing and declare a different velocity, so it's going to be moving in the opposite direction. So this one is moving in the opposite direction, this one is moving in this direction. And we're going to import both of those vectors. So I'm going to create a vector, I'm going to call it cval for current velocity. And then a vector, I'm going to call it nval for neighbor velocity. I'm going to copy this, I'm going to copy both of these. Okay, and let's plug in the right attribute. So cval, I'm going to import the velocity of the current point, or the v vector, and this is the v vector of the neighboring point, and that's going to be nval. So if this is true, if the class is correct, we want to check for the dot product. So we want to do if the dot product of nval and cval is less than 0.6 or 0.5, let's go with 0.5, this condition is true. So we're going to wrap all of this inside this for each, all of this inside the for each. And if the dot product, yeah, this is correct, cval and nval. So that, okay, and if it's not true, then we're going to continue. We're going to keep the same result. So with this check now added, we don't care about the magnitude of the velocity. We want to normalize them, so it's always 1 because we only care about the direction of this. So normalize cval and nval. And then if this is true, set it to red, otherwise it's black, but I don't know why it's showing white now. And we can reduce this amount as well. And let's try if it's higher than 0.5. And nothing is happening. So let's check why is that. And actually right now they're opposed to each other, so let's put them facing the same direction, and that should disappear, and it did. And the last thing we want to do is I'm gonna remove this, and I'm gonna set the color ahead of time to be black on all the points. So just equal 0, 0, and 0. And then if it's true, we want it to change the color. If not, then we don't want to do anything. So right now they're facing they're aligned, both velocity, they're pointing in the same direction. We can take a look at that. You can see they're both in the same direction. If we flip one of them, they're facing each other and they're gonna collide, and that's when this is gonna start to show up. And let's set this to 0, maybe minus 0.05, because we can control that as well. Looks like it's not. Yeah, it's not taking any. It's not changing based on the indices, and that's fine. Okay, so it's either yes or no, which is fine. Okay, so that's our system for checking the velocity, and all we have to do now is this. So let's import the original geo. Okay, and I'm gonna import this, copy this, and let's go here. And I want to transform this geometry, but right now it's we don't have enough points to work with. So what I'm going to do is I'm going to scatter a lot of points onto this, and let's do it after we have it here. So I'm going to scatter points, make sure the name attribute is set, and then let's copy this node and replace the other things with name. So string here, and this is name. I know the class is not 100%, it's not accurate, but you can change this to CName and NName for better clarification. And there we go. That's our velocity check and intersection working. Let's reduce this to 0.1. And right now it looks like everything is intersecting. And the last thing we need to do is, apart from checking the velocity, we need to check the velocity magnitude as well. And that's something we can do as a post process. So we can do a second. We can delete all the points at this level. It's higher than 0.5. So those are all the points that have intersection, and then we can use another point VOP to check for the velocity magnitude and only capture the pieces that are moving. So length of val, and let's do another blast, and let's fit the length of velocity between 0 and 10. Okay, cool. So let's delete anything that is lower than 0.5, and now we're left with only the pieces that intersect and have velocity higher than 1. Now the other thing that we could do is the same approach that we did for this. We can check 3 frames ahead, and if the point is still emitting, we can we can turn that off. And that's pretty much it for the emission. I'm gonna import the original file just to show you guys the result. And I'm gonna I just remembered that we have one more thing that we could do. So this is the emission of the entire geometry, and I do believe that I'm not using the velocity here. So at this point I haven't computed, I haven't deleted with the velocity magnitude, so we can do it now. Yep. So we can delete and keep only the points that have higher velocity. And we could do the trick for, we can't. Let's see if I'm lucky enough. So we could copy back. Yeah, I don't have an ID attribute. I wanted to do the trick of copying the points, but I don't have an ID attribute on this, so I have to, I can do it now. But you guys get the idea. Okay, and let's plug this into the same DOP network and see how that looks. So every time something hits or intersects with anything, ground or not with the ground but with itself, we're gonna get an emission, and we can control the distance and separation we want, and how accurate the result, how accurate the emission we want it to be. We can also increase the number of points if we didn't have enough resolution. Here, if we wanted to have more points, you can see there's not plenty of points there, but we can change that. It's really fast to compute. And that's pretty much it for this video. The next one, I'm going to take a look at another different emission method, and we'll continue in the next lesson. Thank you guys for watching, and